Okay, so welcome, and today we're going to start talking about exponential growth and decay functions, particularly certain types of models. And in this case here, we have a typical growth model, and so we have the function y equals y naught, or y sub 0, which is the initial value of the function. And then we have the exponential part, e to the kt, where k is a positive constant. What we call the growth constant. Now, functions like these show up quite a bit in natural sciences. You've got growth functions like of animals, bacteria, you name it. And then you've got decay functions that come up, for example, in radioactive decay, things like that. Now, if we take the derivative of this, we get y prime is equal to, well, this is just a constant, and this is a constant, so what do we get? Well, we get, by the chain rule, we get k times y naught e to the kt, which is equal to k, because this whole thing is y. So we get k times y. And so we see the growth constant is directly proportional to the current value of the function. Okay? And that's an important characteristic of exponential functions, growth functions like these. Okay? And so what we're going to do next is we're going to, by the way, before I get into that, this is what we call a differential equation because it has it involves differentials in the equation. So we've got the differential here, the derivative. So this is an equation that involves the function and the derivative of the function. And so we call this a differential equation. And we're going to talk about these a little bit later when we get to intro to differential equations. So that's going to introduce our first rule that we're going to talk about as far as the exponential growth model. And so we'll start with that next time.